All right, hello guys. We'll be going over assessment video 9A. And so the problem asks, a company uses a compressed string to shoot, a company uses a compressed spring to shoot 2.5 kilogram boxes up a 1 meter high ramp into a truck, as shown in the image above. The spring has a K equal to 500 newtons per meter and is compressed 0.36 meters. At what speed do the boxes enter the bed of the truck? And then they want us to find if it can enter the truck if it's affected by friction from sand. So to solve this problem, we're going to be using this formula up here at the top. This is conservation of energy, and it's what we've been learning in class. And the whole point of using this is just to show that like we can solve these type of problems, which normally would be really lengthy, by using kinematic equations. And instead we can just use conservation of energy equation and to make it way easier. So to start, we can start by writing down our left side here, our potential or our initial kinetic and potential energies and our initial work. And so we have that our kinetic initial kinetic energy just going to be 1/2 times the mass times the initial velocity squared. And since it's not moving yet, it's just going to be 0. Then we can write our potential. And so since it's a spring, we're going to have it 1/2 times the spring constant times the distance that it's compressed squared. Going to be 1/2 times 500 times 0.36 squared. That's just going to give us 32.4 joules. And then since there's no external force on it, we can just set work external 0. There we go. So now we can go ahead and start trying to calculate our final kinetic energy. Is just going to be the same equation except using the final velocity. And then our potential is just going to be the force of gravity. It's just mass times gravity times the height. So we'll have that it's 2.5 times 9.81 times, and since it's just 1 meter, it's just going to be 1. And we'll end up with 24.53. Let's just round it right there. Joules. So now we can just plug all of these values onto both sides of the equation, and we'll have 0 plus 32.4. That's our initial potential energy. 0 is equal to 1/2 times of mass velocity final squared plus 4.53. So simplifying this, we can just go ahead and isolate our variables and such. Here we go. We can go ahead and cancel things out, so we can further isolate velocity. And what we'll end up with is the final velocity squared is equal 6.3, and then we can just go ahead and square root both sides, and we end up with the final velocity that the box enters the bed of the truck is 2.509. So that's pretty simple. Way easier than if we were to use a kinematic equations. We'd have to use multiple equations and multiple values, and it's just a whole mess. And so the question then further asks us if it can enter the truck, even if it experiences friction from sand on the ground. And we can basically do the same thing. We already have some values. All we need to really do is add in this external work, which is just going to be Oh, sorry. But it's still gonna be 0. But once the system gets going, we're gonna have a form of energy loss. Is gonna be the work done by friction. And that's gonna be equal to the force of friction, which is the friction constant, mu, times the normal force, times the distance. So let's go ahead and quickly find the normal force. Normal force is just going to be mass times gravity. Maybe 2.5 times 9.81. So we have our normal force right here. Now we have our friction coefficient given to us. It's going to be 0.4. And we know the distance of the sand is 50 centimeters long, aka 0.5 meters long. So we can go ahead and calculate that right here. .4 times 24.525 times 5. We end up with 4.905. So we can go ahead and use the same equation, the conservation of energy, just plugging in an extra value. So we'll have 32.4, and I'm not going to add the zeros because useless. This 4.525. And so here we'll just subtract everything on the right side from the left side to get our variables free. And then we'll end up with equation right here. It's gonna be 0.970 times 2. Gonna be equal to 2.376. And then we can just go ahead and this was squared. Go ahead and square root both sides. And our final velocity, even with the sand, is 1.5. And so indeed, the box does make it into the bed of the truck, regardless of whether there's friction or not from the sand. I hope this helps, guys. I hope you learned a bit more about conservation of energy, and thanks.